When you sent over your picks for this deep dive, I have to admit, electrical engineering wasn't exactly the first thing that sprung to mind.
Really? Surprised to hear that.
Yeah, I mean, don't get me wrong, I get how crucial it is, but I tend to gravitate towards, more cutting edge stuff. But then I took a closer look at what you sent, and wow. History, the job scene now, future trends, you've covered it all. It's like a roadmap, like you're saying, hey, this is how you unlock the secrets of electrical engineering. So, ready to spark things up and take a deep dive with me?
Let's do it. And you might be surprised to learn that for something so essential to our modern lives, electrical engineering's roots are surprisingly ancient.
Oh, tell me about it. Our first stop takes us all the way back to ancient Greece. Honestly, who would thought that rubbing amber on fur was like this pivotal moment in science?
It's pretty wild when you think about it. For them, that was their introduction to static electricity.
Exactly. It's like this simple act that rub some amber and boom, it starts attracting stuff like hair, and suddenly it's a light bulb moment. And from there, centuries of folks digging deeper, trying to figure out this whole electricity mystery.
It really makes you appreciate the power of observation and curiosity, right?
Totally. And speaking of capturing something powerful, fast forward to 1745, and we've got the Leyden jar.
Ah, yes, the Leyden jar. Essentially, it was the original capacitor.
Right. And what I find so cool about it is that it wasn't just some scientific party trick.
Not at all. The Leyden jar was a game changer because it proved that we could actually store up static electricity and then release it when we wanted to.
That's a pretty big deal, right?
Huge. It was like a major leap towards actually controlling this invisible force, not just observing it.
Okay, so we've gone from the ancient Greeks noticing static cling to actually bottling it up. Now hold on to your hats because things are about to get really electrifying. The year is 1820, and we meet Hans Christian Ørsted, who stumbles upon this mind-blowing connection between electricity and magnetism. Before him, these were seen as completely separate things.
Totally. And then Ørsted goes and discovers that an electric current can actually move a compass needle.
Seriously.
Just by having electricity nearby.
Yep. And that, my friend, was a total game changer. It proved that electricity could create magnetism.
And that one discovery, I mean, that's like the foundation for everything, right?
Pretty much. I mean, think about it. Motors, generators, all the stuff that powers our world, it all traces back to Ørsted's discovery. It's hard to overstate how massive that was.
Okay, so now we're cooking. And this is where it gets really juicy for me. We're talking about the rock stars of electrical engineering here. Edison, Tesla, Westinghouse, and their epic showdown. The War of Currents. Direct current versus alternating current sounds like something straight out of a comic book. It was an epic battle of ideas, for sure, and the stakes were high because it literally shaped how we get power even today.
All right, break it down for me. What was the big deal with AC versus DC?
So Edison was all about direct current, or DC. It's great for short distances, think like your phone charger. But Westinghouse, along with the genius of Tesla, saw that alternating current, AC, was the way to go if you wanted to efficiently transmit power over long distances.
And ultimately, AC won out, right? I mean, our houses are all wired for AC.
Yeah, you're right. AC became the standard for power grids, making it possible to bring electricity to homes and businesses far and wide. It's why we can have power in places miles away from the power plant.
Makes sense. But I gotta say, for as fascinating as that whole era is, there's one invention that always blows my mind. The transistor. You know, the one they came up with in 1947. The source called it a total game changer, and I'm dying to know why.
Okay, imagine this. A tiny switch, no moving parts, that can flick on and off millions of times every second, controlling electrical signals.
Wait, hold up, no moving parts? How does that even work?
That's the beauty of it. It's all about semiconductors and the way they control the flow of electrons. But the important thing is, because there's no mechanical stuff to wear out, transistors are incredibly reliable. And get this, they're tiny, which meant we could start making electronics smaller and smaller.
So basically, our smartphones that have more power than those old room-sized computers, it's all thanks to the mighty transistor.
They got it.
Yeah.
And those tiny transistors led to something even more powerful, integrated circuits, or ICs.
Right. Those things are insanely small and powerful.
Tell me about it. Back in the late 50s, early 60s, someone figures out how to cram thousands, then millions, and now billions of these transistors onto a single chip. That's an integrated circuit, the brain behind everything, your smartphone, your laptop, basically any gadget you can think of.
It's like this domino effect of innovation, one discovery, paving the way for the next. And it leads us right to
the digital revolution.
Exactly. And that revolution is still going strong today. It's mind-blowing how those early pioneers basically set the stage for everything we rely on today. They really laid the groundwork for our digital world. And speaking of, one of the sources you shared dives into electrical engineering jobs. And I gotta say, the sheer range of options is kinda overwhelming.
Yeah, that's the thing about electrical engineering. It's not just one career path, you know? It's more like a launch pad into tons of industries and specialties.
Seriously, like I was blown away by the list. It's like any cool tech that's shaping our world right now probably has an electrical engineer behind it somewhere.
Exactly.
Okay, so can we like maybe break it down a bit? I mean, the source mentioned a bunch of fields, but it'd be great to dig into some real world examples if you're up for it.
Yeah, let's do that. Let's see. Something tells me you're a bit of a gadget geek.
Busted. I may or may not have a weakness for shiny new tech toys.
Well then, let's start with consumer electronics. That whole world is a massive playground for electrical engineers.
Okay, yeah, that makes sense. But what are they actually doing? Like, what's their role in all the cool gadgets we use?
Think about it. Smartphones, laptops, those smart home devices that everyone's going nuts for, all that sleek design, user-friendly interfaces, it's all thanks to the intricate circuitry and the complex systems that electrical engineers dream up.
Hold up. So when I'm marathoning my favorite shows, I can thank an electrical engineer for making sure my streaming is running smoothly.
You bet. Not just that, even the device itself. Making sure the battery lasts through a whole season of your show, that's them too.
Wow. Okay, so they're like the unsung heroes of our binge watching habits.
Uh-huh, pretty much. But it's not all about gadgets, right? Remember our rock stars from earlier? Edison, Westinghouse, Tesla. Their legacy lives on in a big way in the world of power systems.
Oh, right. It's easy to forget about the whole keeping the lights on thing when you're caught up in the latest tech gizmos.
Exactly. I mean, you don't really think about it until you have a power outage. And then it's like, oh, right, electricity, that's kind of important. But seriously, electrical engineers are absolutely essential in that whole power systems world. They're the ones making sure we have that reliable flow of electricity to our homes, businesses, everything. They work on generation, transmission, distribution, the whole shebang.
Okay, so gadgets we can geek out on, power grids keeping our world running. What else we got?
How about the internet? We're constantly connected, sharing everything, streaming everything. None of that happens without the brilliant minds of electrical engineers working behind the scenes in the world of telecommunications.
It's like the internet's this invisible world, and they're the ones building it and keeping it running, right?
Spot on. They design and maintain these super complex networks that make global communication possible. It's pretty mind-blowing when you think about it.
Totally. And are there electrical engineers working on like self-driving cars and stuff? Because that blows my mind.
You're thinking control systems. It's another field that might surprise people, but trust me, it's huge. Imagine a world without automation. It'd be chaos.
Aha, yeah. No thanks.
Right. But seriously, electrical engineers are the masterminds behind those systems that control everything. From those robots you mentioned to airplanes, even traffic lights, it's all them. They're ensuring efficiency and safety across so many industries.
Wow, it's amazing how much of our daily lives are actually shaped by electrical engineering, even if we don't realize it. It's like this unseen hand guiding so much of our world.
And get this, it's only going to become more prevalent, especially with the push for renewable energy sources, which is another area where electrical engineers are playing a vital role.
Yeah, that makes sense. We're all trying to find ways to be more sustainable. So what are they doing in the renewable energy field specifically?
They're on the front lines, designing and optimizing things like solar panels, wind turbines, even energy storage systems. They're the ones making sure we can actually transition to a greener future.
It sounds like electrical engineers are straight up shaping the future, literally. But I gotta ask, with all these amazing advancements happening now, what's next? I'm dying to know where this field is headed next. You know what really gets me fired up? The future.
Well, buckle up, because the future of electrical engineering is looking pretty electrifying. I'm not going to lie. We're talking about technologies that sound like they're straight out of science fiction, but they're quickly becoming our reality. It's a pretty exciting time to be in this field.
Okay, so we've gone from those ancient sparks to like the digital age and covered all the cool stuff electrical engineers are doing right now. But like I said, what really gets me going is the future. So, spill the beans. What'd you find in your research about where electrical engineering is headed? What's next?
Well, get this. The future of electrical engineering is crazy exciting. We're talking about technologies that sound like something straight out of a sci-fi movie, but they're becoming real and fast.
Ooh, okay, now you've got my attention. Give me some examples, like what are some of the big trends that jumped out at you?
One of the most mind-blowing things on the horizon is smart grids. Imagine a power grid, right? But it's not just delivering electricity, it's actually helping you save money on your electric bill.
Okay, now you're speaking my language. How would that even work?
It's all about two-way communication. So our current power grids, they're like a one-way street. The power company sends you electricity, and that's it.
Yeah, that's pretty much how I think of it.
Right. But a smart grid, it's got sensors everywhere, and it uses digital communication so that the power company and the consumers are always talking to each other.
Oh, interesting. So it's like instead of me just passively getting power, I'm part of this whole conversation with the grid.
Exactly. Let's say you've got solar panels on your roof, right? With a smart grid, when you've got more energy than you're using, boom, you can sell it back to the grid, which could mean, like, way lower electricity bills for you.
All right, I'm sold. Sign me up. What else is in store for the future?
Well, remember that whole smart home thing we talked about
Oh,
earlier?
yeah, like where my fridge orders groceries for me. I'm here for it.
That's just one small piece of a much bigger picture. And that picture is the Internet of Things.
The Internet of Things, or IoT, as the cool kids call it.
You got it. It's the idea that everything is connected. Our homes, cars, cities, everything. And the best part, it's already happening.
No way, really?
Oh, yeah. And electrical engineers, they're like the architects of this interconnected world, designing those sensors, figuring out how everything talks to each other, and making sure it's all super energy efficient. I mean, think smart cities that can, like, monitor traffic and cut down on those soul-crushing commutes, or factories where machines are so smart, they basically fix themselves before they even break. The possibilities are limitless.
I love it. Okay, so we've covered smarter energy in a world where everything's connected. What about those super sleek electric cars everyone's talking about these days?
Ah, yes. EVs are a prime example of how electrical engineering is driving us toward a more sustainable future, and the real star of the show there is the battery. That's another area where electrical engineers are making some serious breakthroughs.
Totally. But how much further can we really push battery tech?
You'd be surprised. It all comes down to something called energy density. Basically, how much juice you can pack into a given space.
Ah, okay.
And right now, electrical engineers are experimenting with all sorts of wild new materials and designs to make batteries that charge faster, last way longer, and are even better for the environment.
So we're talking like longer ranges for electric cars, less time spent tethered to a charger, all that good stuff.
You got it. Remember the formula? E equals V times Q.
You're really putting me on the spot here, but yeah, vaguely.
It means the energy stored in a battery is all about voltage and charge. So by getting creative with those, engineers are building batteries that can power an EV for hundreds of miles on a single charge. It's a pretty exciting time.
Mind-blowing. But even with those supercharged batteries, EVs still need to plug into the grid, right? Which brings us back to those crazy fast communication networks we talked about.
Bingo. And it's not just about EVs either. As we use more and more data-heavy technologies, things like virtual reality or even like telemedicine, where doctors could operate remotely, we need communication networks that are faster and more reliable than ever.
Makes sense. And that's where electrical engineers come in.
Exactly. They're the ones pushing the boundaries of what's possible with 5G and beyond. It's thanks to them we'll soon have download speeds that make our heads spin.
It's wild. Okay, so we've covered smart grids, a hyper-connected world, electric cars, and lightning-fast communication. Anything else you're dying to share before we wrap up?
There's one more thing I've got to mention. Quantum computing. It's a game changer, really. Picture a computer so powerful it makes our best supercomputers look like toys.
Quantum computers, huh? Okay, I'll bite. I have no idea how those work, but they sound awesome. Break it down for me.
So, regular computers use bits, right? Which are either a 0 or a 1. Quantum computers use qubits. And get this, a qubit can be a 0, a 1, or both at the same time.
Hold up, both at the same time? How is that even possible?
It's a quantum mechanics thing called superposition. And honestly, it's a bit mind-bending. But the bottom line is, this lets quantum computers do calculations way faster than regular computers, like exponentially faster. We're still early in developing them, but the potential is enormous.
So we're talking like curing diseases, designing totally new materials, even modeling something as complex as a human brain, but with like perfect accuracy.
Exactly. That's the power of quantum computing, and it's closer than you think.
Wow, okay, that's a lot to take in. We've covered so much ground, from smart grids to quantum computers, and I have to say, I'm seriously impressed. It seems like electrical engineering is at the forefront of pretty much every major tech change that's coming our way.
It absolutely is, and it's only going to become more important as we keep innovating and trying to solve some of the world's biggest challenges, like climate change and resource scarcity.
Absolutely. So for anyone out there who's like obsessed with tech and wants to be a part of building the future, I think it's safe to say electrical engineering is the field to be in. It's got this rich history, it's crazy relevant right now, and the future. It's wide open and full of potential. Who knows what amazing things we'll discover. Thanks for taking this deep dive with me. I've had a blast.
Anytime. It's been fun.